Okay, to continue this section, I had to pause the video here. So we are on the inverses here. So if I use that inverse property, if I notice the bases are the same, it just simplifies down to the x there. This one here, the bases are the same, so this whole thing simplifies down to negative 3x. This one here, the bases are not the same, so we cannot simplify that. However, I can make 64 a base of 2, so I can rewrite this as log base 2 of 2. 64 is 2 to the 6th. So this could be 2 to the 6x then. Okay, now the bases are the same, so this whole thing simplifies down to just 6x. This one here doesn't look like the bases are the same, but they are, because natural log is the same as log base e. So this is going to simplify just to 20. Okay. Finding inverses. Okay, so back here we're just using these inverse properties to simplify expressions. Okay, so notice that the bases are the same, we can simplify those. Finding inverses is just like finding inverses in the other section. Now, if it starts as an exponential, its inverse is a logarithm. If it starts as a logarithm, the inverse is an exponential. So to find the inverse, we're going to, just like in the previous chapter, chapter 6, we swap the x and the y, and then we have to solve for y. But in this case, solving for y means we need to change it into a logarithm based on the logarithm rule here. Okay, so back here we're going to set everything equal to the exponent, and it's going to be log base 4 of x. So these two functions are inverses. This one, number 2, this one starts out as a logarithm, so its inverse is an exponential. So we swap the x and the y, and now we solve for y. So 3 to the x equals y is how we'd set that one up. So this is the inverse. Okay, this one's natural log, same as log base e. So let's substitute the x and the y. I'll actually write as log base e. And now we have to put it in exponential form. So it's e to the x equals y minus 5. Okay, now I have to just add the 5. And I've got the inverse. Okay, this one, let's see, it's exponential, so the inverse is going to be a log. This is going to be a little tougher. So I'm going to switch these. And now I have to solve for y. So we got to be careful here. We have to divide by 2 first. And now we have to put it in log form. So log form means we set everything equal to the exponent. And it's log base 3 of x over 2. And we got to add 1 to the other side. And that would be our inverse. Last thing in this section is graphing logarithms. So because a logarithm is the inverse of an exponential, its graph is symmetric on the line y equals x, so this diagonal here. So we know an exponential has a horizontal asymptote. A logarithm has a vertical asymptote. Okay, so how are we going to graph this? Well, the easiest way to graph these, I believe, is to put them in exponential form. So I'm going to change this equation into exponential form. So it's going to be 3 to the y. Whoops. 3 to the y equals x. Okay, and then I'm going to graph that by setting up a table. But here's the trick. I'm going to plug values in for y to get x. Okay, so let's plug -1, 0, and 1 in there for y. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. Okay. So 1/3 is -1, 1 is 0, and 3 is 1. So this graph is going to look like this. So now the other thing on this is domain and range. It's kind of flip-flopped here. The domain are x values that are greater than 0 here because it's a vertical asymptote here. So we can't plug negative values in. The range is all real numbers, or all y. Because we can substitute anything in for y here and get a result for x, but we'll never get a negative result as we raise numbers to a power. Okay, we'll graph some more complicated ones in class, but that's just the general idea of the graphing part of logarithms.